Today we want to go over section 1.1 and 1.2. 1.1 is talking about definition of a statistic, probability, and key terms. It's just more about the definitions. First, we want to learn about data. What is data? Data is the collection of all the observation, measurement, the result from the survey, everything that we collect for any statistical study is called data. And a statistic, what we do in this semester, is the science of planning the study, collecting data, organize the data, put them in the table on the charts, analyze the data, and then interpret those data and make conclusion based on the data. But usually in some statistical studies, the population is very large and we don't have access to the whole population. So in those cases, we choose a sample, which is a group of the population. We randomly select a group of population as a sample, and then we do the study over the sample group. And at the end, we make the result based on the sample for the whole population. So as I said, population is the collection of all measurement, percent, object, everything in that study. If we collect the data from all of the population, from everyone in the population, in the groups of peoples or the object that we study on, that means we are doing the census. Census means collection data from every member of the population. But the sample is a sub-collection. That means we have a whole population. We know which group are we going to do the study on them, and then but we don't have access to all of them. That we select some of them as a sample, and we do the study on the sample. So let's look at an example. Is that in a survey of 410 human resource professionals, 148 of them said that the job candidates were disqualified because of information found on social media posting. Okay, what is the sample here? What is the population? Population, so as you see, it says a survey of 410 human resource professionals. So that means this study is on the human resource professionals. So when we say what is the population, in this case, the population is all human resource professionals. But we're not going to go to do this study on all of the human resource professionals. We only give the survey to 410 of them. So 410 of those human resource professionals who surveyed are the sample. So all human resource professionals, the population, and 410 human resource professionals who were surveyed are the sample. More definitions. What's the parameter? What's the statistic? What's the variable? Parameter, it's a number. It's whatever that describes the characteristic about the population. But the statistic is a number or whatever that describes the characteristic of a sample. Everything that describes the population is called parameter. Everything that describes sample is called statistic. Variable is is a number, is whatever that we want to collect on that study. You have set up in a study, the whole population, you have a group of sample, and those numbers that you want to collect for your study is called the variable. But the actual number that you collect are called data. Okay? Let's look at an example. It says in this, determining this example that the underlying number is a statistic or parameter. We said that the parameter, that's everything that describes the whole population. A statistic describes the sample. That means a group of the population, not all of the population. So the first example, in a study of all 4,444 employees at the college, it is found that modifying 40% own a television. Okay, so the study is just on it. It's on all 4,444 employees at the college. So that means the study is under all employees in the college, which means the study is about the whole population. So that means that result, the 40% that we get as a result of those, the percentage of the people who own a television, is the result that we have for the all population, which means that's a parameter because it's describing the whole population. In the second example, it says in a study of all babies born at the hospital in one state, it was found that 51.7% of the babies were girls. Is this number a statistic or parameter? Okay. 51.7 of the babies were girls. It's a study on all babies at a hospital in one state. So in this study, the population is all babies at that hospital in that state, that certain state. And this result that 51.7% of them are girls, that's a result from the whole population. Describing the population, that means that's a parameter. Next example. In the United States, a survey of about 9,400 individuals aged 15 and over found that such individuals spend an average of 5.19 hours per day engaged in leisure and sports activities. Okay, we have a study in the United States, and the study is on the individuals aged 15 and over. So if I ask you what's the population in this study, the population is all the individuals aged 15 and over. All the individuals aged 15 and over are the population. But the survey is just on 9,400 of them. That means those 9,400 individuals who were surveyed are their samples. And this result is the result that comes from the sample just for those 9,400 individuals. And the result, everything that describes the sample, it's called a statistic. So that is a statistic. Second example, the freshman class at a university has an average SAT math scores of 514. The study is on the freshman class at a university, at a specific university. And these result that 500 for the result of SAT math score is a result for all freshman class at that university. That means that's a result that comes from the all population, which means describing the population. So that means that's a parameter. Okay, so let me just erase the board. Okay. Next example. Now it says in this example, determine what the key term refer to this is, the following study. A study was conducted at a local college to analyze the average cumulative GPAs of the students who graduated last year. Let's match these words with those statements and see what's the population, what's the sample. So when you look at the study, it says that the study is at a local college and it wants to analyze the average GPAs of the students who graduated last year. So what's the population? Population is all the students who graduated last year because the study is on those people. So all the students who graduated from the college last year, which means F. That's the population. What is the sample? Sample is always a group of the population. When the population says all the students who graduated from the college last year, so the sample is a group of a student who graduated last year. And we know the sample must always be selected randomly. So the sample is D. We said the parameter is describe a characteristic about the population. When the population is all the students who graduated from the college last year, so parameter must describe them. That means the parameter is the average GPA scores of the student who graduate, all the students who graduated last year, which is the average GPA scores of a student who graduated from the college last year, which is G. Statistic describes the characteristic about the sample. That means only those graduated students who participated in this study. Okay, so the average GPA score of the students who of some students who graduated from the college last year. Okay, I'm so sorry. This is, so we said the parameter is must be about the population. So I didn't read them carefully. The average GPA scores of students who graduated from the college last year, that's all of the students, that's the parameter, but only those that participated in this study, the average GPA scores of the student who graduated from the college last year and participated in this study is a statistic. That's the G. Variable is the average GPA score. That's right. That's a GPA score because that's what we collect from the population or the sample. The GPA of students who graduated from the college last year, which is B, and the data are those specific GPAs are the numbers, which is C. Okay. In next part of this section, we want to talk about the two different branches of a statistic. We have two different branches in a statistic, descriptive statistic and inferential statistic. Descriptive statistic is when we organize a study, we need to collect the data, organize the data, summarize the data, put the data in table, charts, find the average. Everything that we do on the data is called descriptive statistic, part of the statistic. But when we have samples and we use a sample to make a conclusion about the population, it's called the inferential statistic. Half of this semester, we go over the descriptive statistic, the first half of the semester. We learn how to collect the data, to organize them, put them in table. And after that, in the second half of the semester, we learn how we use sample data to make conclusion about the population, which is the inferential statistic. And the probability, which is one section, one chapter of this semester, is just a mathematical tool that we use to study randomness. And it usually deals with the chances of occurring any event in that study. Okay, that's all in section 1.1. Now we want to go over 1.2. Okay. In section 1.2, we talk about the different type of data, how different methods for sampling, and the variation that we have in data and sampling. We said the data are the numbers that we collect from the survey or the results that we collect from the survey, from observation, measurement, based on the different studies. We have two types of data, quantitative and qualitative. Qualitative data or categorical data are the data that are names or just labels. For example, we have a study about the gender of the professional athletes. So the result that we get from the survey is just if the athletes are male or female. So the results are just some words, male, female. It's not a number. So that is called the qualitative data or categorical data or attribute. Or we have a study about the eye color of people, the place of birth of people. So we just have the name of some color, name of some cities. The result that we get when we ask people about the eye colors, we just have some names like brown, black, and blue, green. We don't have a number as a result. Okay, so these are all called qualitative data. Even if in a study we have shared numbers on professional athletes uniform, so we may say, okay, the shared numbers are numbers, but those numbers on the athletes uniform are not the numbers that we use, to add or subtract them by each other. It's just a label for each player. We say the player number 7, player number 10. There's no order between them, it just works. They are numbers, but it works as a label. So that's why it's called the qualitative data. But quantitative data or numerical data are when we have numbers as a data. For example, we collect the weight of supermodels. Weights are numbers. 120 pounds, 130 pounds, 145 pounds, or when we collect data about the age of respondents in the survey. Age are numbers, the temperature numbers, everything. Whenever we collect the data, we get numbers, we call it the quantitative or numerical. When we have quantitative data, we can describe them as a two group, as a discrete or continuous. What is discrete data? So discrete and continuous is when we have quantitative, when we have numbers, okay? When do we say that numbers are discrete? When do we say numbers are continuous data? Discrete means when those numbers are finite or countable. They cannot have any number. They just can have only some finite numbers, some specific numbers. For example, we says the number of tosses of a coin before getting tails. Okay, you may roll the die just in after first toss you get the tail, maybe after 5 tosses, after 10 tosses, or maybe 100 tosses, but they're numbers. You never can say, okay, after 3.5 tosses, I got the tail. You can't have any number, just some specific numbers, 1 or 2 or 3. We have some finite or countable numbers. So it's called discrete. And whenever you see the word the number, that is called discrete. Continuous means the result that we get, it can have infinitely many possible values for them. Infinitely many numbers, okay? Like the length of the distance between 0 to 12 centimeters. Between the 0 and 12, we can have different distances, like 0.5 centimeters, 0.7 centimeters, 0.85 centimeters, 1.72 centimeters, 11 centimeters. We can have any numbers, as a distance between the 0 and 12. So that's called the continuous. Let's look at some examples. It says determine whether each of these data are qualitative or quantitative. If it's a number, we say quantitative. If it's not a number, we say qualitative. A homeowner measured the voltage supplied to his home on 27 days of a given month, and the average value is 122.6 volts. Okay, they measured the voltage. Voltage is a number. When we have a number, that means that's a quantitative. Number 2, the number of programs installed on various computers. Okay, the number of programs, like, I may install 1 program or 2 programs or 5 programs or 10 programs. So for sure, the results are numbers. So that means they are quantitative. But now, when we have quantitative, we can say if it's a discrete or continuous. When we say the number, that means it should be a finite number. It should be a countable number. So that is a discrete. Okay, next example. It says for each of these items, indicate whether the data is qualitative or quantitative. And if it's quantitative, if it's a number, specify whether it's continuous or discrete. The number of pairs of shoes you own. The number of pairs, one pair of shoes, two pairs, three pairs, it's a number. It's quantitative. But it's quantitative. Is it discrete or continuous? It's discrete because it's talk about the number of pairs. The type of car you derive. The type of car is just some names. Okay, we can have Honda, we can have Toyota. It's just a type of car, it's just a name, it's just a label. So it's qualitative. The distance is from your home to the nearest grocery store. Distance is a number. Is it 1 mile, 2 mile, 0.5 miles? It's a number, so that's quantitative. If it's number, we can say if it's a discrete or continuous. Since the distance can be any number, that is a continuous. Next question, the number of classes you take per school year. You may have only 1 classes, you may have 10 classes, 5 classes, 6 classes, is a number, so that's quantitative. Now, if it's quantitative, we can say if it's discrete or continuous. So we never say we have 5.5 classes in this semester. Just 1 or 2 or 3 or 4 or 5, so that's discrete. The type of calculator you use. We have different types of calculator like TI-83 or TI-84 or TI-30. So it's just a name. The results are some names, so it's qualitative. Weights are numbers, so it's quantitative. And since weight can have any number, that is continuous. The number of correct answers on a quiz. 1 correct answer or 2 correct answers or 5 or 10 is a number, is quantitative. But since it's talking about the number is finite. So that's a discrete. We said whenever we have large population, we collect a group of population as a sample and we do the study over on the sample. Okay, now we want to see what are the different sampling methods that we have to choose the samples out of the population. Something that's important, that the sample that we choose out of the population to do the study must be selected completely random. Okay, because we want to avoid any bias. So since we want to be completely random, the first method is just called the simple random sample. That means every possible sample, every possible member or the object in that population have a chance to being chosen for the sample. For example, we have a class of 40 students, we want to select a sample of 5. So to be completely random, every student in a roster has a number, okay? Because the names are alphabetically in order. And then we randomly pick some numbers. And those numbers can be generated by some calculators or just some website to make sure that we have completely random sample. The next method is called the systematic sampling. Systematic sampling means we have a group of population. We put them in order, or just make a list of all the population. Then we select at one point and then select every kth element in that population. For example, we start from the 3rd person and then we select every 6th one. We start from the 1st one and we select every 5th one. It's called a systematic sampling. Convenient sampling means just choosing the people who are easy to get. which is not the best option because most of the time it's not a random sample, okay? The next sampling method is called a stratified sampling. Stratified means you divide the population into at least two different subgroups. But the groups that you put the population into that have to have the same characteristic. For example, for groups of population people, we can put them into two groups of men and women because they have the same characteristic. And then we draw a sample, a random sample from each subgroup. We pick some people out of the men group and we pick some people out of the women group. We pick some out of each group. But in cluster sampling, it's similar to stratified because we need to divide the population into different sections, or which is called clusters. But this time we randomly select some sections and we survey all of the members, all of the objects on that section. Okay, in a stratified, we randomly select some out of each group, but in cluster, we select some groups and survey all of the members on that group. That's the difference. And multi-stage sampling is just when we use more than one sampling techniques. So let's look at an example. Either we want to see what are the sampling techniques that we need to use for each of them. It says you divide the students' population with respect to majors and randomly select and question some students in each major. Okay, divide this population based on their majors. When we divide the population into groups, it's one of the stratified or cluster. But when if it's with respect to the majors, that means we want to have a groups based on these same characteristic, which is called the stratified. In a stratified, we question some out of each group. Next question. You assign each student a number and generate random numbers, then question each student whose number is randomly selected. It's obvious. It's a simple random sample. Next example. You select the students who are in your Math 11 class. You want to do a study, but you just select some students who are in your Math 11 class. People who are easy to get. Convenient sampling. Next example. The author collected data by randomly selecting 35 pages from the previous edition of this book and then counting the number of words on each of these pages. Okay. So it says select 35 pages of the book. If you look at the book as a whole population, each page of the book is called a section of that book. And is randomly select 35 sections, 35 pages of the book. Okay, and then counting the number of words on each of those pages, all the number of words in each of those pages. So when we select some sections and we go over everything in that section, it's also clusters. We learned about the different technique that we can use for choosing a sample out of a population. But even, if you have a good plan and just use all of these sampling techniques, we still may have a chance of error in the result. When we have a sample, we select a sample random, okay, and we do the study over the sample, we get the result, but we see that there is a discrepancy between the sample result and the true population. This is called a random sampling error. Okay. That's a kind of sampling error, but we have non-sampling errors as well. That means we select the samples completely random, but there are other factors like we have wrong data, so we have the wrong calculation. In that case, when we see the discrepancy between the sample result and the population, this is called a non-sampling error, human error. And non-random sampling error, it's when you choose a sample, you choose technique, you select techniques to choose samples that are not random, like you use convenience sampling method. So you don't have a random sample. So it's called a non-random sampling error. Okay. So next part, as I said, these sections are mostly definitions. Next section, the next part is talking about the common sources of bias. We may have a sampling bias. When you choose a sample, which is not which is not representative of the whole population, that's a sampling bias. When do we have voluntary response bias? When the sample, when you choose the samples based on who is volunteer. In that case, we have a voluntary response bias because usually the people who are volunteer that they have a type of opinion about that case, and they are not completely random. When we self-interest study, or it's a kind of sampling bias that occurs when the researchers have an interest in the outcome. If in a study, we see that the researcher has an interest in the outcome, that's called a self-interest study. That's a type of bias. Response bias is also a sampling bias where the responder gives inaccurate responses. Perceived lack of anonymity happens when the responder fears giving an honest answer because the answers might have a negative effect on their life. Loaded questions, it's a kind of sampling bias when the wording of the question to get the result influence the responses. And non-responsive response bias is also a sampling bias where people refuse to participate in the study. When we set up a study, we need to avoid all of these bias. We have to select the samples and set up the study in a way that none of these bias occur. Let's look at this example. He says 12 nutritionists are each paid $100,000 to try a new celebrity diet on 10 of their clients and then write a report summarizing the result. Based on the sample result, it is found that the diet is effective for 118 out of the 120 people. What is wrong in this study? The study, it's about a new celebrity diet. Who is the researcher? Researchers are nutritionists. Okay. What do you see here? Self-interest study. When the researcher have an interest in the outcome. As you see, nutritionists have interest in obtaining the result as favorable to their backers. This is what is wrong about this study.